Hello guys, welcome back to my YouTube channel. Today I am going to learn about coordinate geometry. In the coordinate geometry, first we learn about distance formula. Distance formula is under root of x2 minus x1 whole square plus y2 minus y1 whole square. Let us do one problem. Find the distance between a point 0, 0 and 36, 15, where 0, 0 is known as the origin if the x-axis and the y-axis is 0. So, given a is equals to 0, 0 and b is equals to 36, 15. The distance between AB is equals to under root of x2 minus x1 whole square plus y2 minus y1 whole square. AB is equals to, here the value of x1 is 0, the value of x2 is 36, the value of y1 is 0, the value of y2 is 15. So in the place of x2 we substitute 36 minus x1 is 0 into whole square plus y2 means 15 minus 0 whole square, which is equals to under root of 36 whole square plus 15 whole square, which is equals to under root of 36 into 36, which is equals to 1296 plus 15 into 15, which is equals to 225, and the sum of 225 plus 1296, which is equals to 1521, and the square root of 1521 is 39, since the distance between the AB is equals to 39. Now go to the next problem. Verify whether the point 1, 5, 2, 3 and minus 2, minus 1 are collinear or not. How to find a collineer? If the distance between the AB plus BC is equals to CA, then it is said to be a collineer. Note that. Solution: let A is equals to 1, 5, B is equals to 2, 3 and C is equals to minus 2, minus 1. The distance between the AB is equals to under root of x2 minus x1 whole square plus y2 minus y1 whole square. Here, if we consider AB, so x1 is equals to 1 or y1 is equals to 5. Here x2 is equals to 2 and y2 is equals to 3. So under root of, in the place of x2 we substitute minus x1, which is equals to 1 square plus y2 3 minus y1, which is equals to 5 whole square. 2 minus 1, which is equals to 1 square plus 3 minus 5, which is equals to minus 2 whole square, under root of 1 plus minus 2 whole square, which is equals to 4, which is equals to under root of 5, since the distance between the AB is equals to root 5. Now we find the distance between a BC. If we want to find a distance between the BC, then consider 2 as an x1 and 3 as a y1, minus 2 as an x2, or minus 1 is equals to y2. We have formula to find the distance: x2 minus x1 whole square plus y2 minus y1 whole square, under root of, in the place of x2 we substitute minus 2 minus x1 means 2 whole square plus y2 minus 1 minus y1, which is equals to 3 whole square, which is equals to under root of minus 2 which is equals to minus 4 whole square plus minus 3 minus 1 which is equals to minus 4 whole square. Minus 4 whole square which is equals to 16 plus 16 under root of 16 plus 16 which is equals to under root of 32 and the root of 32 which is equals to 4 root 2. Now we find the distance between a CA which is equals to, if we want to find the distance between a CA, the coordinate of C is equals to minus 2 comma minus 1 and the coordinate of A is equals to 1 comma 5. Minus 2 is considered as x1, 1 is considered as a x2, minus 1 is considered as a y1 and 5 is considered as a y2. So the distance formula is x2 minus x1 whole square plus y2 minus y1 whole square which is equals to under root of x2 means 1 minus x1 minus 2 into whole square plus y2, in the place of y2 we substitute 5 minus y1 minus 1 whole square which is equals to under root of 1 minus into minus plus 2 whole square plus 5 minus into minus will get plus 1 whole square which is equals to 2 plus 1 which is equals to 3 whole square plus 5 plus 1 which is equals to 6 whole square under root of 3 square is equals to 9 plus 6 square is equals to 36 and 36 plus 9 is equals to 45. Root 45 can be written as 3 root 5. So for the condition for the collinear is the distance between the AB plus the distance between the CA is equals to the distance between a CA. The distance AB is plus BC is equals to CA. The distance between the AB is root 5 plus the distance between the BC is 4 root 2 which is equals to the distance between the CA which is equals to 3 root 5. Hence they are not equal since it is not collinear. Find a relation between the x and y such that the point x comma y is equidistant from the point minus 2 comma 8 minus 3 comma minus 1. It means that the point x y has an equal distance with minus 2 comma 8 and minus 3 comma minus 5. So how to take it? The formula of distance is x2 minus x1 whole square plus y2 minus y1. Here in the place of x1 we have x, in the place of y1 we have y, and which is equals to under root of x2 minus x1 whole square plus y2 minus y1 whole square. Here x2 is minus 2 and y2 is 8, but in here the x2 is minus 3 and y2 is minus 5. So in the place of x2 we substitute minus 2 minus x whole square plus in the place of y2 we substitute 8 minus y square which is equals to under root of, here x2 is minus 3 minus x1 is x whole square plus y2 is minus 5 minus y whole square, because it is a distance between the x comma y and minus 2 comma minus 8, and it is a distance between the x comma y and minus 3 comma minus 5. As in the question it is given that both the distance are equal, so we take equal. Under root of minus 2 minus x can be written as 2 plus x whole square plus 8 minus y whole square can be written as y minus 8 whole square. Minus 3 comma minus x can be written as 3 plus x or x plus 3 whole square plus minus 5 minus y can be written as y plus 5 whole square. So a plus b whole square is equals to, we know that the expansion of a plus b whole square is equals to a square plus b square plus 2ab. So the expansion of 2 plus x whole square is equals to x square plus 4 plus 4x plus y minus 8 is in the form of a minus b whole square. We also know the expansion of a minus b whole square, which is equals to a square plus b square minus 2ab. So the expansion from y minus 8 whole square is equals to y square plus 8 is 64 minus 16y, which is equals to, similarly x plus 3 whole square is equals to x square plus 9 plus 6x plus y square plus 25 plus 10x. It can be written as x square plus y square plus 4x minus 16y, 64 plus 4 which is y square plus 6x plus 10y plus 25 plus 9 which is equals to 34. Square get cancelled. X square plus y square plus 4x minus 16y plus 68 is equals to x square plus y square plus 6x plus 10y plus 34. Y square x square, y square x square get cancelled. We get 4x minus 16y plus 68 is equals to 6x plus 10y plus 34. If we shift this term, all these terms to right hand side, it will become, first we write this term 6x plus 10y plus 34 minus 4x plus 16y minus 68 is equals to 0. 6x minus 4y which is equals to 2x plus 10y plus 16y which is equals to 26y minus 34 minus 68 which is equals to 34 equals to 0. If we divide all this term by 2, we get x plus 13y minus 17 is equals to 0. Since this is a relation between x and y, what we have to find? It is given that the distance between a p and q is 10 unit. We should have to find the values of y. So p is equals to 2, minus 3. Let consider 2 at x and minus 3 as y1. Q is equals to 10, y. Consider it as x2 or y as y2. The distance between a PQ is equals to 10 unit. So the formula to find the distance between a PQ is x2 minus x1 whole square plus y2 minus y1 whole square, which is equals to 10 under root of the value of x2 is equals to 10 minus the value of x1 is equals to 2 square same plus value of y2 is equals to y minus the value of y1 which is equals to minus 3 square is equals to 10 under root of 10 minus 2 which is equals to 8 square plus y minus into minus which is equals to plus 3 whole square is equals to 10 under root of 8 square is equals to 64 plus y plus 3 whole square is equals to 10 if we apply square on both sides, then under root of 64 plus y plus 3 whole square into square is equals to 10 square. Squares root get cancelled. The left terms are 64 plus y plus 3 whole square is equals to 10 square, which is equals to 100. So 64 plus, it is in the form of a plus b whole square. Y plus 3 whole square is equals to a plus b whole square. The expansion of a plus b whole square is a square plus b square plus 2ab. So in the place of a we have y, or in the place of b we have 3. So y square plus 3 square is equals to 9 plus 2ab, which is equals to y square plus 9 plus 6y. So in the place of y plus 3 whole square we can also write y square plus 9 plus 6y is equals to 100. Y square plus 6y plus, which is equals to 73, is equals to 100. Y square plus 6y is equals to 100. If we shift plus 73 to that side, it will become minus 73. So y square plus 6y is equals to 27. It can be also write as y square plus 6y minus 27 is equals to 0. Y square plus 6y minus 27 is equals to 0. If we do factorization, first we have to multiply the highest order terms with constant y square into minus 27, which is equals to minus 27 y square, and the factors of minus 27 y square is equals to 93 or 39, and minus is obtained as plus minus or minus plus. If we subtract minus 3y from 9y, which is equals to 6y, or if we subtract plus 3y from minus 9y, which is equals to minus 6y. So in the place of 6y we can also write plus 9y minus 3y. Y square plus 9y minus 3y minus 27 is equals to 0. So if we take y common, we get y plus 9 minus, if we take minus 3 common from both the side, we get y plus 9 is equals to 0. Y plus 9 is common in both the terms, so we take it as common, y plus 9, and the left terms are y minus 3 is equals to 0. Yes, y plus 9 is equals to 0, y minus 3 is equals to 0. Y is equals to, if we shift plus 9 to other side, it will become minus 9, and if we shift minus 3 to other side, it will become plus 9, since a value of y is either minus 9 or 3. Question, it is given that p is equals to 4, 3. Let us consider it at x1 or it as y1, and q is equals to 8, 5. Consider it as x2 or it as y2, and it is given that it is divided in the ratio of 3:1. It means that m1 is to m2 is equals to 3:1. So the value of m1 is equals to 3, the value of m2 is equals to 1. We have a section formula m1 x2 plus m2 x1 by m1 plus m2 comma m1 y2 plus m2 y1 by m1 plus m2. The value of m1 is equals to 3. The value of x2 is equals to 8 plus the value of m2 is equals to 1. The value of x1 is equals to 4 by m1 plus m2, which is equals to 3 plus 1. the value of m1 3, the value of y2 which is equals to 5 plus the value of m2 is equals to 1, the value of y1 is equals to minus 3 by m1 plus m2 3 plus 1 same. 3 8s are 24 plus 1 into 4 which is equals to 4 by 3 plus 1 which is equals to 4, 5 into 3 which is equals to 15 plus minus 1 into 3 is equals to 3 by 4. 24 plus 4 which is equals to 28 by 4, comma 15 minus 3 which is equals to 12 by 4. 4 1s are 4, 7s are 4 1s are 4 3s are. So 7 comma 3. 7 comma 3 at a resultant coordinates which divides aligned segments PQ in the ratio 3:1. Centroid of a triangle whose vertices are given. Let P is equals to 3 comma minus 5, Q is equals to minus 7 comma 4 and R is equals to 10 comma minus 2. Let us suppose it as x1 comma y1, x2 comma y2, x3 comma y3. It means the value of x1 is equals to 3, the value of y1 is equals to minus 5, the value of x2 is equals to minus 7, the value of y2 is equals to 4, the value of x3 is equals to 10, the value of y3 is equals to minus 2. The centroid formula is x1 plus x2 plus x3 by 3, comma y1 plus y2 plus y3 by 3. Centroid is denoted by G, which is equals to the value of x1 is equals to 3 plus the value of x2 is equals to minus 7 plus the value of x3 is equals to 10 by 3, comma the value of y1 is equals to minus 5 plus the value of y2 is equals to 4 plus the value of y3 is equals to minus 2 by 3. 3 plus minus is equals to minus 7 plus 10 by 3, comma minus 5 plus 4 as it is plus minus is equals to minus 2 by 3. 3 minus 7 which is equals to minus 4 plus 10 by 3. Minus 5 plus 4 which is equals to minus 1 minus 2 by 3. Minus 4 plus 10 which is equals to 6 by 3. Minus 1 minus 2 which is equals to minus 3 by 3. If we divide 6 by 3 we get 2 and minus 3 by 3 which is equals to minus 1. Hence we obtain a vertices of a centroid is 2 comma minus 1. Even A, B, C, D are taken in order which are the vertices of a parallelogram. So, first we draw a parallelogram and take our vertices in order such as A, B, C, D. Solution. We should have to show that it is a parallelogram. How do we show that it is a parallelogram? The AC and BD are diagonals of a parallelogram, we know that. So the midpoint of the AC and the midpoint of the BD are equal. If the midpoint of the AC and BD are equal, then it is said to be a parallelogram. First, we take the diagonal AC. The vertices of A is equals to 7, 3. Let us consider 7x x1 or 3x y1. The coordinates of C is 8, 2. x2 as 8 or y2 as 2. The midpoint of AC. How to find the midpoint of AC? We have a formula to find a midpoint of AC or midpoint of anything is x1 plus x2 by 2 comma y1 plus y2 by 2. In this, the value of x1 is equals to 7 plus the value of x2 is equals to 8 by 2 comma the value of y1 is equals to 3 plus the value of y2 which is equals to 2 by 2. 7 plus 8 which is equals to 15 by 2 comma 3 plus 5 which is equals to 5 by 2. It cannot be further divided. So let it same as it is. Now we have to find a midpoint of BD. The coordinate of B which is equals to 6 comma 1. So compare it with x comma 1. We get x is equals to 6, y is equals to 1. The value of D is equals to 9 comma 4. Now take 9 as x2, 4 as y2. The midpoint of BD is same as it is. We have a formula x1 plus x2 by 2 comma y1 plus y2 by 2. The value of x1 which is equals to 6 plus the value of x2 which is equals to 9 by 2 comma the value of y1 is equals to 1 plus the value of y2 which is equals to 4 by 2. 9 plus 6 which is equals to 15 by 2 comma 4 plus 1 which is equals to 5 by 2. From the equation 1 and equation 2 we can observe that the coordinates midpoints of AC is 15 by 2 comma 5 by 2 and the midpoint of BD 15 by 2 comma 5 by 2. They are equal, hence they are the vertices of parallelogram. 3 coordinates are there. We should have to find the area of a triangle. Let A is equals to minus 5 comma minus 1, which can be written as x1 comma y1. The coordinates of B is equals to 3 comma minus 5. Consider it at x2 comma y2. Now C is equals to 5 comma 2. So consider it at x3 comma y3. To find the area of triangle we have a formula. Delta is equals to 1 by 2 into x1 y2 minus y3 plus x2 y3 minus y1 plus x3 into y1 minus y2 which is equals to 1 by 2. The value of x1 which is equals to minus 5, the value of y2 which is equals to minus 5 minus the value of y3 which is equals to 2 plus x2 3, y3 the value of y3 is 2 minus y1 which is equals to minus 1 plus the value of x3 is equals to 5, y1 value is minus 1 minus the value of y2 which is equals to minus 5. 1 by 2 minus 5 minus 5 minus 2 which is equals to minus 7 plus 3, 2 minus into minus equals to plus. So 2 plus 1 which is equals to 3 plus 5 minus 1 minus into minus plus, it means minus 1 plus 5. So minus 1 plus 5 is equals to 4. The multiplication of minus 5 into minus 7 is equals to 35 minus minus will get plus. Plus 3 into 3 is equals to 9 plus 5 fours are 20 which is equals to 1 by 2 64. If we divide 64 by 2 we get 32. Since the area of a triangle is equals to 32 units. To find the area of a triangle by using a Heron's formula, we have triangle is equals to under root of s into s minus a, s minus b into s minus c, where s is equals to a plus b plus c by 2. How to find the a plus b plus c by 2? In a triangle, if The vertices are A, B, C. Then the opposite of A is equals to small a, the opposite of B is equals to small b, the opposite of C is equals to small c. Since the distance between the AB is equals to C, the distance between the BC is equals to A, and the distance between the AC is equals to B. Now first we should have to find out A. A means a distance between a BC. How to find the distance between a BC? We have a formula, under root of x2 minus x1 whole square plus y2 minus y1 whole square, which is equals to under root of BC. Here B is equals to 6, 3 and C is equals to 2, 6. X2 means 2 minus x1 means 6 whole square plus y2 means 6 minus y1 which is equals to 3 whole square, under root of 2 minus 6 which is equals to minus 4 whole square plus 6 minus 3 is equals to 3 whole square, minus 4 whole square which is equals to 16 plus 3 square is equals to 9, under root of 16 plus 9 which is equals to under root of 25. The perfect square of 25 is 5. Hence the value of A, or the distance between a BC, is equals to 5. And now we have to find B. B can be calculated by calculating a distance between the AC. So to find the distance we have a formula, x2 minus x1 whole square plus y2 minus y1 whole square, under root of the coordinates of A is 2, 3. The coordinates of A is 2, 3 and the coordinate of C is 2, 6. So consider it at x1, y1, x2, y2. So the value of x2 is 2 minus the value of x1 is equals to 2 whole square plus value of y2 which is equals to 6 minus y1 which is equals to 3 whole square, under root of 2 minus 2 is equals to 0. 0 square is nothing but 0 plus 6 minus 3 is equals to 3 square, which is equals to under root of 3 square. Squares root get cancelled, we get 3. The value of B is equals to 3. Now we have to find a value of C. The value of C is equals to the distance between the AB. To find the distance we have a formula, x2 minus x1 whole square plus y2 minus y1 whole square. The coordinates of A is equals to 2, 3 and the coordinates of B is equals to 6, 3. Now consider it at x, y or it at x2, y2. The value of x2 is equals to 6 minus the value of x1 is equals to 2 whole square plus the value of y2 is equals to 3 minus y1 is equals to 3 whole square, under root of 6 minus 2 which is equals to 4 square plus 3 minus 3 which is equals to 0 and 0 square is nothing but 0. So under root of 4 square, squares root get cancelled, we get 4 since the value of C is equals to 4. Now to find the S we have a formula, S is equals to A plus B plus C by 2. The value of A is equals to 5 plus the value of B is equals to 3 and the value of C is equals to 4 by 2. 5 plus 3 plus 4 which is equals to 12 by 2. If we divide 12 by 2 we get 6 since the value of S is equals to 6. Now delta is equals to, the actual Heron's formula is delta is equals to under root of S into S minus A into S minus B into S minus C, under root of the value of S is equals to 6 and S minus A, the value of S is equals to 6 minus the value of A is equals to 5 the value of h is equals to 6 minus the value of b is equals to 3. The value of s is equals to 6 minus the value of c is equals to 4. Under root of 6 as it is 6 minus 5 which is equals to 1, 6 minus 3 which is equals to 3, 6 minus 4 which is equals to 2, which is equals to under root of 6 into 1, 6 into 3 into 6, 3 into 2 which is equals to 6. It can be written as 6 square. Squares root get cancelled since the area of a triangle is equals to 6 unit. Given coordinates are 4, minus 8, 5, minus 2. Consider it at x1, y1 and it at x2, y2. In the question, we should have to find the slope of a line passes through both the coordinates. So we have a formula to find the slope of a line. M is equals to y2 minus y1 by x2 minus x1, such that it has a condition x2 does not equals to x1. x2 is 5 and x1 is equals to 4. Since x1 is not equals to x2, the value of x2 is equals to minus 2 minus the value of y1 is equals to minus 8 by the value of x2 is equals to 5 minus the value of x1 which is equals to 4. Minus 2 minus into minus plus 8 by 5 minus 4 which is equals to 1. And if we subtract minus 2 from plus 8 which is equals to 6 by 1, since the slope of a given coordinate is equals to 6.